So in this video I'll explain the trapezoidal method by double integration. The formula for the trapezoidal rule of double integration is I is equal to h into k. H and k are the your strip size divided by 4 into bracket f of x naught y naught plus f of x naught y1 plus f of x naught y3 plus, or you can say I'll take consider x1 y1 plus f of x1 y2. Okay, this is the formula. So I'll tell you what is f of x naught y1 naught x naught y1 and all that. So generally this can be calculated, or you can see that you have to form the table in the form of the table has to be formed in this type. Thus the x naught value, and this will be the y1 value, y naught and y1. So f of x naught and y naught, f of x naught y1, f of x1 y naught, f of x1 y1. These are the four values which we'll substitute into this equation to get the your value of I, that is your double integration by trapezoidal formula. Okay, so how to do that? So generally when you make this table, then you have to multiply, or you can take this as a plus this plus this plus this. So it all four values, the corner of the sum of corner values will give you the your this value. I can write, I can be written as a h into k divided by 4 into bracket there are sum of corner values of a table. Okay, this is your formula for the trapezoidal. Same way if I consider Simpson rule, Simpson's rule by double integration, that time it will be I'll write the again x naught x1 x2 y naught y1 y2. So this will be f of x naught y naught, f of x naught y1, this will be f of x naught y2. Similarly we'll get f of x1 y naught, f of x1 y1, f of x1 y2. So here will be f of x2 y naught, f of x2 y1, f of x2 y2. Okay, these are the value we will get. So in this case so this first value, the last value, generally 0. If we have to consider x naught value, means x naught y naught, then x naught y2 value, then this value x2 y2, then x2 y naught. This will be a square. This 4 value you have to add it. That means this value, this value, and this value, and this value, we have to add that. Then you have to take in the form of rhombus. So this values, so this values you have to add it, then multiply the center value. So the formula will be I is equal to h into k by 9 into bracket sum of values of f of xy, which will be in the form of your square. That means this value, this value, this value, this value you have to add it. Okay, so plus 4 times of sum of your f of x value in a rhombus shape. That means this value, this value, this value, and this value, plus 16 times of center value. Okay, so that will be center value. If you take it, that will be a Simpson rule value. Okay, so we'll solve one problem to understand the both the method. So in this video I'll explain one numerical by double integration method. The given question is I is equal to double integration of 0 to 1 0 to 1 divided by 1 plus x plus y dx into dy, and the h and k value they have given as a 0.5. So start with this numerical. So 0 to 1 is nothing but y naught into yn, and this is x naught into xn. So yn first y0 is 0, the lower limit, the yn upper limit 1. Similarly x0 is 0 and x is equal to 1. So this limits will be denoted as the x0 and xn, y0 and yn, x0 and xn. The lower limit is considered as x0, upper limit considered as xn. So now so we'll calculate your x0 value, xn value, x2 value. For doing that, first we'll prepare one table which is nothing but x0, x1, first calculate the values. So x0 is 0, then we'll calculate x1. x1 is nothing but x0 plus 1 times of h. So if I substitute, then I'll get 0.5 because x0 is 0 plus 1 into 0.5 will be 0.5. x2 will be x0 plus 2 times of h. So I'll get 1. x0 is 0 plus 2 into 0.5 will be 1. So we have to find out the values of x1, x2, x3, so on till the value will be equal to the xn. So in this case, x2 will be xn, so we have to stop it over here itself. So then y0 will be 0, y1 will be y0 plus 1 times of k, which is nothing but 0.5 because k is also 0.5. So y0 is 0, 0 plus 1 into 0.5 will be 0.5. So y2 will get it as a y1 because 1 into 2 times of k will be 2 into 0.5 plus 0 will be 1. So here also y2 will be equal to yn. We have to stop it over here. Then we'll form a table to get the x1, x2 values with respect to y2, y0, y1, y2 values. Okay, so we already seen in the your theory part how to form the calculate the your values with the your trapezoidal formula. So first we'll form it in the form of x0, y0, y of x0, y0, f of x0, y1, f of x0, y2. So this will be f of x1, y0, f of x1, y1, f of x1, y2. This will be f of x2, y0, f of x2, y1, then f of x2, y2. So we need to find out all those values. Then we have to take this square plus this square plus this square plus this square. If you substitute into the formula of your trapezoidal, so we'll get the value of I by trapezoidal formula. So to find out these value, first we'll calculate all this value. So x0, y0 is nothing but f of x0 is 0, y0 is 0, f of 0, 0. Then f of x0, y1 will be nothing but f of 0, y1 is 0.5. Similarly, f of x0, y2 is nothing but f of 0, 1. So f of xn, y0 is nothing but f of 0.5, 0. F of x1, y1 is nothing but f of 0.5, 0.5. These value we have to substitute into this equation to get these value and substitute in this table, and in a table with this table we will calculate the value of your I by using the trapezoidal formula by double integration. So this will be f of x1, y2, which is nothing but f of 0.5 into 1. Similarly, x2, y0, 1, 0, f of x2, y1, which is nothing but 1, 0.5, f of x2, y2, which is nothing but f of 1, 1. So if I substitute these value into the equation of 1 plus x plus y, so if I substitute this, so 0 plus 0 will be 0, 1 divided by 1 will be 1. Similarly, 1 divided by 1 plus 0 plus 0.5, so it will be 1 by 1.5, which is nothing but 0.667. So then 1 divided by 1 plus x is 0, y is 1, so 1 by 2, 0.5. So similarly, 1 divided by 1 plus 0.5 plus 0, so again it will be 0.667. So then substitute 0.5 value, 1 divided by 1 plus 0.5 plus 0.5, 1 by 2, so this will be 0.5. Similarly, if I substitute this, so 1 plus 0.5 plus 1, 2.5, 1 by 2.5 will be 0.4. So 1 divided by 1 plus 1 plus 0, so 0.5. 1 divided by 1 plus 0.5, 0.25, so it will be 0.4. Then 1 1, so 1 divided by 1 plus 1 plus 1 by 3, so 0.334. These are the values. So I'll write all this value in the table form again. If I add the values in the table form, x0, x1, x2, y0, y1, y2. So f of x0 y0 is 1, f of x0 0.5 is 0.67, then 0.5, 0.667, 0.5, 0.4, 0.5, 0.4, 0.34. So we know the formula of your trapezoidal, which is nothing but I is equal to h into k divided by 4 into bracket sum of corner values of square. So we'll form the square. This is your 1 square, second square, third square, and this will be fourth square. That means sum of corner values of square means when you add 1 plus 0.667 plus 0.5 plus 0.67, this is first square, plus second square will be 0.667 plus 0.5 plus 0.4 plus 0.5, this is second square. Similarly for all 4 square you have to find out. So then I is equal to h is 0.5 into k is 0.5 divided by 4 into bracket 1 plus 0.667 plus 0.5 plus 0.667, this is first square, plus second square is nothing but this, so 0.667 plus 0.5 plus 0.4 plus 0.5, this is second square, plus third square which is this 0.5, 0.4, 0.334, 0.4, so 0.5 plus 0.4 plus 0.334 plus 0.4, then fourth square is 0.667 plus 0.5 plus 0.4 plus 0.5. So this is the your all values. So if I calculate I value, then I'll get value as a 0.5376. This is the value of your I by trapezoidal method. Similarly, if I calculate the Simpson rule, the Simpson rule formula is I is equal to h into k divided by 9 into bracket sum of corner values of square plus 4 times of sum of values of rhombus plus 16 times of center value. So corner value is nothing but this will be the your corner. This is the corner values. Then the rhombus values this, and this. This will be center value. So if I calculate, then it will be 0.5 into 0.5 divided by 9 into bracket corner values are 1 plus 0.5 plus 0.334 plus 0.5, these are the corner values, plus 4 times of rhombus values 0.667 plus 0.667 plus 0.4 plus 0.4, okay, plus 16 times of center value which is 0.5. If I calculate the value, then I'll get 0.5229. Okay, like this we can calculate the values by Simpson and the trapezoidal rule. Okay, thank you.